So I'm going to show y'all how to do a one-step equation when there's a fraction, super duper easy. So when we're looking each side by 3 to get the x by itself, and I'm left with x is equal to -8. How I teach. Everybody learns differently, so I'm going to present each subject as easy as possible, and if I can, in multiple ways, like written notes, which will always be attached to the lesson, visuals, graphic organizers. I do, then you do, which is what you'll see us doing most of the time when it comes to the actual math problems. And you might even see me do a song and dance to help you learn. To be proficient in algebra, you must do the practice, and everything is based on steps. So if you don't understand the basics, then you can't move on to the next level of problems. It's really important that you get this. So here are my written notes for this section, and you're going to see me present notes for equations multiple different ways. This one is specifically for just one-step equations. So the goal is to get the variable or the letter by itself. I always use the opposite sign to move numbers from one side to the equal to the other. So imagine at that equal sign that you have a wall. Whatever you do to the left of the equal, you also have to do to the right, or vice versa. And you're always going to use the opposite sign. So with addition, it's subtraction, subtraction, addition, multiplication is division, and division is multiplication. Regardless of what your answer is, you can always check it, and I highly recommend you do this on a test. What you do is you take that number and you plug it back into your equation, and it should make it true. So now I want to use the scale as a visual on solving equations. So on the left is what the traditional view is, which is that you have a scale and it is perfectly balanced, okay? On the left is stars, on the right is tickets. On the left, the stars equal M's, and there are 3 stars, so that means 3 M's. And then on the right, we have 9 tickets, which are just single units. And down here on the middle right here would be where my equal sign is. So my answer is C. Now, if I wanted, you can look at it and see that 3 times 3 is equal to 9. And so 9 is equal to 9, which is still a perfectly balanced scale, okay? And that's really the end result. But I think what may help you understand how to solve equations, I'm going to use the scale as our end result should be where we have m is equal to 3. And this is perfectly balanced because there is one term on the left and one term on the right. And our term on the left isn't just any term, it's just the variable. So if I take our equation, which is 3m is equal to 9, right now this equation is kind of lopsided because there's a 3 and an m on the left and there's a 9 on the right. So if I took 3m and divided it by 3 on both sides, my 3's cancel out, which we'll go through this a little bit further, and 9 divided by 3 is my 3. So as you see now, as far as numbers and variables and numbers and equals and all this other stuff, we have one variable, not 3 m's, but just the m is equal to 3, which makes that a perfectly balanced answer. So if you look at this problem, in your head, you can automatically say that v is going to be equal to 5. You just know that. You can kind of visualize it. You really don't have to do any work, but that's not really the purpose of all of this. You can also see that this is kind of lopsided. We want to get that v by itself. So we're going to draw our wall down the middle here. We're going to subtract 8 from both sides because we have a positive 8. Now we're going to do a minus 8 or a negative 8, which is the same thing. Our 8's cancel out because plus 8 minus 8 gives me 0, and 0 just goes away, and I'm left with the v. Now, on the right now, we're going to have 13 minus 8, which is 5. And 5 is my answer. And it's also balanced. If we use the Mrs. Z way, we have a letter on the left and a number on the right. Woohoo! That's the way we want it to be. So I'm always going to show you at least one check during each lesson. So on this one, if we take what v was equal to, which was 5, and we plug it in for v, so we have 5 plus 8 is equal to 13, and 5 plus 8 is 13, and it's equal to 13. This is a true statement, so we got the right answer. Now it's your turn to try. Please pause the video and try the problem and then start up again once you're finished. So our first step is to put our wall here. Next step, we want to get the a by itself, so we're going to subtract by 3. And I'm left with a is equal to 17 minus 3, which is 14. If you got 14, awesome. Now we can move on. If you did not get the 14, please look at where you made your shmee. A shmee is a stupid math error. Again, on this problem, we're going to put our wall here at the equal sign. The only difference is that the variable is on the right instead of the left, which is okay. If we're looking at the 8, it has a minus in front of it, which makes it negative. So we are going to add 8 to both sides. I'm going to drop that v down, and v is equal to 13 plus 8, which is 21. If you wrote this as v is equal to 21, that is also correct. Now it's your turn to try. please pause the video and try the problem. Restart after you're finished. We're going to draw our wall first. We're going to add 3 to both sides. Since we have a minus 3, our 3's cancel out. I'm left with A. 17 plus 3 on the left is equal to 20. Awesome. If you got it, that's great. If not, please check to see where you made your shmee. Now we're going to start with multiplication. The relationship between the 4 and the C, so 4C is the same as 4 times C, okay? I'm just kind of putting this here on the side so you can see that. So if we're doing multiplication, we're going to want to do division to get rid of our 4. Remember to put your wall there. Now, 4 divided by 4 is 1, and that just goes away, okay? Now, 1C is the same as just C. This is implied. So we're just going to drop that C down. And again, we have these little notes here on the side. C is equal to 6. Your turn to try. Please pause the video and you know the drill. I'm going to draw our line. We're going to divide each side by 3. And we get C is equal to 9. So if you wanted to do the check here, you could do 3 times 9. 3 times 9 is equal to 27. 27 is equal to 27, which is true. So the only difference on this problem is that we have a negative 5D. Here's my wall. And we're going to divide each side by the negative 5. Now, in multiplication, if you have a positive number times a positive number, that equals a positive number. A minus times a minus also equals a positive number. A negative times a positive equals a negative, and a positive times a negative equals a negative. So here we have negative 5 divided by negative 5, so it's going to be a positive 1 or just D. 35 divided by negative 5, so a positive divided by a negative gives me a negative 7, and that is just my answer. Your turn to try. The rules don't change. The only difference here is that it's a negative 63. So pause the video and try the problem. Here's my wall. Divide each side by 7. D is equal to negative 9. So let's look at the problem on the left. That is a typical problem that you're going to see on a one-step equation, where you have a letter over a number. This right here, that line is just division, okay? So there's no reason to get scary with it. And if we set up this problem like a proportion, because 10 is like 10 over 1, okay, we could solve this problem by using cross multiplication. And it is probably the easiest way to solve this type of problem. So cross multiplication is where we go over the equal sign, like so. H times 1 just gives me H. 1H is the same thing as H. And 3 times 10 is equal to 30. Not too hard, eh? Same thing here, we could do our check. Look at our original problem, and we would have 30 over 3 is equal to 10, which gives me 10 is equal to 10, which is also true. You know the drill, so please pause the video and try this problem. So I'm going to rewrite this as a proportion. I'm going to cross multiply. And I get H is equal to 40. So x over 5 is the same as 1/5 x. The only difference is that you move the x up to the top, okay? That's why it's the same. So if we had a negative 1/5 x, that's like, and I'm going to show you the why, is because we have negative is like a negative 1 times 1/5 times x. Now, those numbers are all over 1, right? So if we multiply them across, we're going to end up with negative 1 times 1, which is a negative 1, times x, which just gives me a negative x. On the bottom, I have 1 times 5 times 1, which is just 5. So this problem is the same as negative x over 5. So all we're doing is we're basically, this is the y up here on the right, this is y. But the easiest way to do it is just to move the x and the negative up. So this is now going to be negative 2x over 3. Now the reason why we're doing this will make a little bit more sense in one of the future slides. Now it's your turn to try. Pause the video and fill all of these out. So again, all we're going to do is we're moving the x and a negative up to the top. So this would be 3x over 4. This, we're going to move that up and the x up, and we get negative 1x, or just negative x on top, over 3. And then on this last one, we would do, or down here, oh, it wants us to do it the opposite way, which would have been just 1/5 x. And here we're just going to move that x up to the top, and we get 3x over 7. All we're going to do is move that x and that negative up. So we end up getting a problem like on the right, which these two problems are basically the same. And all we did is we took 10 and put it over 1. Now the reason why we did that is so that we would have a proportion. And when we have a proportion, we can multiply over the equal sign. It makes life just a little bit easier. And we end up with negative x is equal to 30. Negative x times 1 is negative 1x, and 3 times 10 is 30. Now we have that x with the negative in front of it, and when I was explaining before, it's like a negative 1 in front of this, right? So this is like a negative 1x, and if we divide it by a negative 1, The negative ones cancel out, and I get x is equal to negative 30. So basically the number on the other side of the variable is just going to flip its sign. So you don't have to necessarily show that every time, but this is the y. Now it's your turn. Please pause the video and you try it out. So our first thing is we're going to rewrite our problem. Our x goes to the top. It's just going to be over 5. And we're going to have negative 8 over 1. We're going to cross multiply. And I get x is equal to negative 40. Because a negative times a positive is a negative. If you got the right answer here, woohoo! We got this. If you didn't get the right answer, please check to see what you did wrong. Here's another problem for us to try. So on this problem, we're going to rewrite it. All we got to do is put that x on top. So we're going to have 2x over 3 is equal to 10 over 1. Cross multiply. This one's going to be a little trickier. We're going to have 2x is equal to 30. Well, if we go look at what we're supposed to do here, we really want to have that x by itself. So we're going to put our line, we're going to divide each side by 2, and I get x is equal to 15. Now it's your turn to try. Pause the video. Again, we're going to rewrite our problem. 3x over 5 is equal to 10 over 1. We're going to cross multiply, and we get 3x is equal to 50. Put my line down, divide by 3, divide by 3. Oh my gosh, we're going to get a decimal, which is fine. And when we do this here, we're going to, and I actually need a calculator for this, we're going to do 50 divided by 3 in our calculator, okay? So when you put it in your calculator, you're going to do 50 divided by 3. I know this is silly for me to show this to you, but some people still don't understand it, so I'm going to show y'all one more time. And when you do that, you get 16.66 repeating. If we round it off, it would be 16.7. Here's our challenge problem. On our challenge problem, we're going to put our line down the middle again, and we're going to want to move the 8. Now the 8 is not negative. The v is negative. So this goes with our v, the negative. So we're going to add 8 and add 8. 8's cancel out. I get negative v is equal to 21. Now, I'm going to go over the y later on. But all you need to know about negative v's is basically all it's doing is flipping the sign on the other side. So if I want a positive v, now my 21 is going to be negative. There's my answer. So the reason why I shared my shmee is I want you to realize that everybody makes it. All you need is a small distraction for it to occur. The one I made actually is very common, So what happened is my brain saw that that negative was right there, and even though I said it was a negative v, my brain interpreted it as a -8, which it's not, and so subconsciously that's what ended up happening. But it's a +8, so we're going to want to subtract 8 from both sides. And we get -v is equal to 5, or v is equal to -5. If we flip the sign, so we can have a +v, everything is now balanced there, and we are ready to go. Here's our challenge problem. On our challenge problem, we're going to put our line down the middle again, and we're going to want to move the 8. Now the 8 is not negative. The v is negative. So this goes with our v, the negative. So we're going to add 8 and add 8. 8's cancel out. I get -v is equal to 21. Now, I'm going to go over the y later on. But all you need to know about negative v's is basically all it's doing is flipping the sign on the other side. So if I want a +v, now my 21 is going to be negative. There's my answer. Your turn to try. Pause the video. If you got -14, you got it right. You are awesome.